hadirin, pihak kami ingin memohon maaf di atas kesilapan teknikal pada video ucap tama sebentar tadi. Kita akan mainkan semula video ucap tama daripada Yang Berusaha Dr. Mio Hamdan, ACM Pegawai Pendidikan Daerah, Pejabat Pendidikan Daerah Timika Selatan. Cikgu Rozana, mohon.
Melalui pembelajaran bersepadu STEM yang mengaplikasikan konteks dunia sebenar yang menggunakan pendekatan hands-on dan penerokaan terbuka. Tema Symposium pada tahun ini iaitu mempelopori masa depan pendidikan STEM melalui cikgootube. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Dan kembali, salam sejahtera, salam Malaysia Madani, salam bela sejahtera 2030, salam langkah hari ini dan maruah anak didik kita. Yang Berusaha Dr. W. Rifai, pengurusi pengayuh Symposium on Science Education 2024, pengurusi Pusat Kajian Pembelajaran dan Pengajaran Universiti Tunku Abdul Rahman, yang berkuasa Symposium on Science Education 2024 yang berbicara tentang Selatan, UTAR, para pembentang pendidik dan juga para hadirin sekalian. First and foremost, I would like to express my deepest appreciation to the organizer, Universiti Tunku Abdul Rahman, for inviting me to deliver the opening speech this morning. Ini merupakan satu penghormatan yang besar pada saya untuk bersama-sama dengan hadirin sekalian, bersama dengan kumpulan pendidik yang berdedikasi, yang komited terhadap kemajuan pendidikan STEM di negara kita. Pendidikan STEM ini merupakan satu pendidikan yang bersepadu yang mengaplikasikan konteks dunia sebenar dan menghubungkan institusi pendidikan, komuniti dan industri untuk melahirkan pangkat dan masyarakat berliterasi ke STEM ke arah pembangunan ekonomi negara. Di antara matlamat pendidikan STEM iaitu melahirkan murid berliterasi STEM yang berupaya untuk mengenal pasti, mengaplikasi serta mengintegrasikan konsep STEM untuk memahami masalah dan menyelesaikannya secara kreatif dan inovatif melalui pembelajaran bersepadu STEM yang mengaplikasikan konteks dunia sebenar dan menggunakan pendekatan hands-on dan penerokaan terbuka. Tema Symposium pada tahun ini iaitu mempelopori masa depan pendidikan STEM melalui pedagogi dinamik, iaitu embracing the future of STEM education terus by dynamic pedagogis amatlah bertepatan dengan keperluan masa kini. Dynamic pedagogis refer to teaching methods that are flexible, adaptive and responsive to the needs of students and learning environment. These approaches emphasize student-centered learning, where the instructor adjusts strategies and techniques based on student feedback, learning progress, and specific context of course. Seperti ini bertujuan untuk berkongsi kaedah pengajaran yang inovatif dan berkesan dalam pendidikan STEM, di mana dengan tekad research and Robinson, the role of creative leader is not to have all the ideas. It is to create a culture where everyone can have ideas and feel that they are valuable. Sebab itu, kalau kita lihat dalam program kali ini, SoSE kali ini, untuk memupuk kesedaran pada pengajaran yang terkini, serta menyediakan peluang rangkaian kepada para pendidik. Saya yakin dengan kerjasama dan dedikasi pada pendidik UPH dapat mencapai matlamat-matlamat tersebut. Di antara objektif yang kita capai iaitu to share innovative and effective teaching methods in STEM education, to create awareness of the current innovative teaching methods and how to embed innovation in the teaching and learning of STEM education, and to provide networking opportunities for STEM educators from various schools, college, and universities. Ladies and gentlemen, embracing a future of STEM education through the pedagogies. First, integration of AI and machine learning in classroom. Bagi contohnya, sistem tutorial berdasarkan AI dalam membantu murid-murid memahami konsep STEM yang kompleks dengan menyesuaikan tahap kesukaran berdasarkan potensi mereka. Yang kedua, virtual and augmented, iaitu kita menggunakan VR and AR as transforming STEM education by creating immersive learning environment. Sebagai contoh, pelajar boleh meneroka model 3D, meleview dalam kimia atau mensimulasikan projek kejuruteraan, menjadikan konsep abstrak lebih konkret dan interaktif. And then interdisciplinary learning, whereas STEM is being integrated with other fields to create STEAM. That is science, technology, engineering, arts, and mathematics. Encouraging creativity alongside technical skills. Itu di mana murid-murid dapat melaksanakan projek yang menggabungkan pengkajian dengan seni digital atau menggunakan prinsip matematik untuk mencipta reka bentuk seni bina. And then gamification in STEM education, iaitu di mana education ini menggunakan gaming involved using game design elements in learning. Ini merupakan satu perkara yang menyeronokkan, yang memberi impak kepada murid-murid untuk terus belajar, terutamanya untuk memastikan embracing in the future of STEM education through dynamic pedagogies. Ladies and gentlemen, now I want to share with all of you as observer from Malaysia in the 10th ASEAN Student Science Project Competition in National Science Museum Bangkok, Thailand, Julai 2024. Apa yang saya lihat di situ adalah pelbagai inovasi yang datang daripada negara ASEAN dan bagaimana idea itu telah dikembangkan. Idea inovasi yang memberi peluang yang untuk meneroka pelbagai idea yang kreatif dan juga inovatif. Selain daripada itu juga, kita juga memberi peluang kepada pelajar kita how they can communicate with each other from other countries, di mana menggunakan bahasa Inggeris secara langsung untuk meningkatkan keyakinan dan potensial murid-murid kita dalam memperkasakan anak murid kita ini sebagai kemenjadian murid karisma masa depan atau future to be student. Terima kasih kepada pihak UTAR yang lagi selama ini telah ambil pelbagai aktiviti antara DPD dan juga UTAR. Dan yang syabas saya ucapkan kepada semua yang menjadi pembentang pada hari ini kerana anda merupakan antara the best speakers yang saya yakin dapat memberi the great idea in our symposium today. With that, it gives me great pleasure to officially open the Science Education Symposium 2024 with the theme Embracing the Future of STEM Education through pedagogies. I hope the symposium will serve as a meaningful platform for the exchange of knowledge and ultimately has a positive impact on STEM education in Malaysia. Thank you so much. See you next. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih Cikgu Diana berkongsi video ucap nama daripada Dr. Mio Hamdan. So diharap perkongsian oleh Dr. Mio Hamdan tentang maksud dinamik pedagogis akan dapat dikupas dengan lebih lanjut oleh 5 penceramah. Tadi Dr. Mio ada sebut 5 penceramah yang terbaik yang akan berkongsi teknik pedagogi dalam pengajaran STEM yang seterusnya akan dapat menarik minat para pelajar. Sebelum kita memulakan, saya ingin meminta bantuan para peserta untuk mengisi sign in form dan kita akan dapat mengisi sign in form dengan tepat ya. Sila isikan semua maklumat dengan betul supaya kita dapat menghantar e-certificate of participation ke email address yang betul. So minta diminta agar mengisi maklumat selengkap yang boleh ya. Ladies and gentlemen, the 2024 Science Education Symposium will continue with a series of talks. The Q&A session will be open during the last 5 minutes of each lecture. For participants who wish to ask a question, please turn on your microphone, introduce yourself, and ask your question. We will begin with a talk by the winner of the 2023 Malaysian Science Foundation Science Education Award, Mr. Pek Chun Ho. Mr. Pek Chun Ho is a physics lecturer from College Matriculas Labuan. He received his tertiary education from University Malaysia Sabah in MED Science and BEd Honours Physics from University Kebangsaan Malaysia. Last year, he was the Grand Prize RM6000 winner in Science Education Award 2023 by Malaysia Tourist Science Foundation. Without further ado, I would like to invite Mr. Pek to deliver a talk on demonstrating RMS current in alternating current by stepping into Arduino microcontroller technology. Ladies and gentlemen, please welcome Mr. Pek Chun Ho.
Okay. All right. Okay. Thank you. First and foremost, I would like to express my gratitude to. Can you listen to my presentation?
Yes, Mr. Pek, loud and clear.
Okay, I would like to express my gratitude to UTAR for inviting me. Good morning to Professor, Associate Professor, lecturers, all educators, students from UTAR. Without further ado, can you see my slide? Can you see my slide?
Yes, Mr. Pek.
Okay. All right. So this is the I'm using Arduino to demonstrate root mean square current in alternating current. So root mean square current, students normally just memorize the definition. Okay. in the lab we don't have physical tools to show physically to students what is mean actually by root mean square current. What is the significance of knowing root mean square current? So today I just want to share about this, how we use Arduino to demonstrate the root mean square current concept. Yeah. Okay. So actually, if you want to know more about this, how to set up the apparatus, yeah, I've published an article about this Arduino in the Journal of Cognitive Science and Human Development. So you can just search the name Arduino, or you can just search under my name, Pak Chun Ho. Yeah, this article will be available in the Google Scholar. Okay, so the reason why I use Arduino, because I like Arduino. The reason why I like Arduino is because I learned a lot of physics concepts behind Arduino, right? A lot of physics concept. So we can use technology, but sometimes we might take things for granted. We ignore how the technology works and the working principle behind it. Yeah. So first and foremost, in physics, we do a lot of measurement for various physical quantities like mass, length, time. Okay, Arduino also can do the same because it has a lot of sensors. All right. The first thing we must understand about Arduino is he can do direct measurement or indirect measurement. Okay, Arduino can only measure two things, which is the voltage. Measure the voltage and time only. Yeah, it cannot measure other things. Actually, it's very simple. Arduino cannot measure other things, other quantity. It can only measure voltage and time. So for other quantities, like now I'm talking about current. How to measure current? Actually, Arduino measure voltage to get the value of current using proportionality method. Of course, there are a lot of other quantities the Arduino can measure. All right. So this is the Arduino kit setup. Okay, I use an extension. Okay, actually my Arduino kit is to measure the current flowing in the extension. Okay, and how much the current used by all the household electrical appliance. Okay, there is a current sensor here connected to the extension wire here. I splice open the extension wire so that I can connect my current sensor, and all the Arduino kits is put inside a disposable container. Okay, the LCD, the Arduino brain, LEDs. Okay, and very simple materials. I use the main component is the Arduino self and the current sensor, and the others are accessories. You need a breadboard, of course, to connect all the circuit. Even the breadboard, I also like it to teach my students to introduce the concept of electrical circuit. What is the mean by how do you connect all the component itself into the breadboard? It replaces all the wires, into a simple breadboard. Yeah, how do you connect the circuit to ground, to the positive terminals? All right. So current sensor is called the ACS712 current sensor. You have to take up to 20 ampere. Yeah, the 20 ampere variant. There are different variant: 5 ampere, 20 ampere, 30 ampere. You have to use the 20 ampere. Okay, because the current measuring is ranging from 0 to 10 ampere. Okay, so the cost is not very expensive. The main cost goes to the Arduino board itself and the LCD. All right, and the others are just very cheap. Yeah, the main cost is the Arduino, but you can do a lot of other projects using Arduino. Okay, so as you can see here, the current sensor is connected to the neutral wire. Yeah, because you can see for the load circuit, you have live wire and neutral wire. Neutral wire, the reason I choose the okay, you can see here, I splice open the extension. They are live, neutral, ground. So I choose the neutral wire because it has lower potential, less risk. Yeah, compared to the brown wire is live wire, it's much riskier, higher potential. But even though it's lower potential for neutral wire, but I still get electric shock before when touching the neutral wire. So for this project, bear in mind, don't let it, we must supervise the students while doing the project, because we don't want to any case of electric shock, yeah, because I get electric shock myself. Okay, so I use the neutral wire. Yeah. So okay, by now, is there any problem about the presentation? Can you hear my presentation?
Everything is clear, Mr. Peck.
Okay, thank you very much. Okay, so all right, for this one thing we must know about this current sensor also got physics concept behind. Yeah, the reason why I like Arduino, because it relates to a lot of physics concept. You know, for this load, it has very high current, 0 to 10 ampere. So my Arduino is a very fragile instrument. Yeah, it measures very low voltage, very small current. So if my current directly goes into the Arduino circuit, of course it will fry the circuit. Okay, so how the current sensor actually works is, the current actually didn't go into the circuit of Arduino. It just passed by the what we call the Hall sensor inside the ACS712. It just passed by, and my Hall sensor detects the magnetic field by the current, generated by the current. So this is related to the magnetic field chapter by students. The current mu naught I/O2 pi r, it generates magnetic field around the wire. So the current sensor didn't actually measure the current directly. It measured the magnetic field generated by the current. And this magnetic field, this current actually just like a magnet. Just like a magnet, under the magnet, yeah, the Hall sensor will produce a Hall voltage, because we know that if electrons flowing through the Hall sensor, so all the electron will be, experience a magnetic force. This is also about electromagnetic induction. The electron will go to one side and it generate the Hall voltage. As I said before, Arduino can only measure two things. It can measure voltage and time. So it cannot measure current. So what do Arduino do is it measure the voltage. It measure the Hall voltage in the Hall sensor. The Arduino measure the Hall voltage in the Hall sensor, and it generate the Arduino can generate the current value proportional to the magnetic field. That means when I have a higher current passing through the load, higher current, you have higher magnetic field. When you have higher magnetic field, you have higher voltage. So the Arduino can sense the higher voltage and thus can generate the current value flowing inside the load. Don't you feel amazing, the physics, the beauty of physics behind this Arduino sensor? Yeah, student, while doing the projects, that's why if possible, if time allows, I would like to explain all the physics involved behind all these sensors. Okay, this as you do know, kid, there's two activities. So first activity is how to visualize the AC graph. Yeah, that means I open this the graph. I open the graph in the serial plotter. In the Arduino IDE, it has a function called serial plotter. It can show a graph. Yeah, generate all the current flow. Yeah, I use a household appliance, clothes iron, toaster, water kettle, wall drill, vacuum cleaner. As you can see here, you have motor based, like wall drill and vacuum cleaner. They are motor based. Clothes iron, toaster, water kettle, they are heat based. So there are two different type of electrical appliance. So household appliance relate to real life. Right. So second activity is I calculate the peak current, root mean square current, and power consumption. Okay, so these are some examples of evidence of students doing the activity. So students checking the label behind the electrical appliance, because the Arduino kit, it measure the peak current, calculate the root mean square current, and after using the root mean square current, it calculate the power consumption used by all the electrical products. So students will check the label to compare whether the power consumption value is it same as what is generated by the Arduino. Okay, thanks to my fellow lecturers who helped me around the projects, conduct the activity in the classroom. These are the example of household appliance. I try to bring in, some real life things into the classroom so that students can feel the significance of the physics concept they learn in classroom. It's not just in the classroom, but it is related to their daily life. So we have wall drill, you have motor base here, and you have heat base here. And the reason why I use extension, because easily I can plug and unplug. I can just turn on the switch, and why I don't connect my current sensor directly to all the electrical appliance. Why I don't splice open the the electrical appliance wire? Why I use an extension? Because why do you need to sacrifice why do you need to sacrifice so many electrical appliance when you have an extension? So that's why I use a extension. So I just measure the current through the extension. At the same time, I can measure the current flowing through every electrical appliance here. Okay, so just use the extension, you can connect, just on and off the switch. Okay, now here are some examples of the graph. It showed this is motor base.
The AC graph shows positive and negative values going up and down. Here you see the vacuum cleaner has initial spike of
wall drill.
Wall drill also shows initial spike of current because they use more power to turn the motor initially.
So you can see here, if motor base, low current, but it has spike of current initial. This is something unexpected. I never expect this thing to happen. I never expect got a spike of current initial. But when I do this project, I feel surprised to see the spike of current initially. It gives me the idea that, to turn the motor, we need more current. So that means it need more current to turn the motor initially. After that, when the motor is already running, we just need a small current to make it still continue moving in a constant velocity. Let's look at the heat product, like the water kettle, the iron, and the toaster.
Toaster that based on heat does not show the spike of current, but it shows big graph all the time. Means it used a lot of power to generate.
So can you see the difference here? The heat product, it uses a lot of current all the time. For heat product, use a lot of current, and it doesn't have the spike of current like the motor. It just show constant current. High current all the time. So this is the difference between the heat and motor. So I never expect this kind of graph will come out, but it really explains. So the cloth iron and toaster use very high current compared to wall drill, and the one with the motor, like wall drill and vacuum cleaner, they show similar graph. They have spike of current, but after that it's all low current. And one more thing I see from this project is it shows that AC current actually has very, very high frequency, 50 to 60 Hertz. That means it's a bit different from what they learned in the lecture note. In the lecture note, they learned that the current has very beautiful sinusoidal graph, But in actual real life, the current has very, very high frequency. And they can check in the electrical label, 50 to 60 Hertz. That means, every second. What is mean by 60 Hertz? That means it is also not just shown in the graph. You can check the label, it also show the same thing. 60 Hertz, that means every second got 60 oscillation. That's very fast. In 1 second, my hand only can make 10 oscillation. But this one, the current, it goes up and down 60 times for every second. So that's one one thing that can be shown to students. So it really shows the real thing to the students. Not the same like the lecture note show the beautiful sinusoidal graph. It actually is very, very high, very, very sharp curve. Very, very sharp graph. Okay. And one more thing surprised me is I learned about thermostat.
Here for the clock iron, we are very surprised when the AC graph suddenly dropped to 0 because the thermostat cut off the current when it reaches.
So when I learned about when I use the clock iron to test the graph, and suddenly the graph becomes 0, and then I check the the LED here is off. That means the thermostat, this is a function of thermostat, it cut off the current. That's why my graph becomes 0. So students learn, this thermostat is to control the temperature, prevent energy loss, or maintain a same temperature. So they learn some unexpected things here. Okay, so that is about the graph, the first activity. The second graph is about how to demonstrate the root mean square current. Why they need to learn root mean square current? Why is it actually mean by root mean square current? Okay, so as you can see here, I checked the peak current and root mean square current for each of different electrical appliances here. So you can see the cloth iron and toaster, they have bigger current. The root mean square current is around 4 to 6 to 7, 4 to 7. But for the wall drill, the motor based one has very low current, 1 to 3 only. Peak current is, peak current can go above the root mean square current. Root mean square current is like the average value, but useful average value. It's not the meaningless average value, it's the useful average value. So peak current can go above it. And peak current is related to the electrical safety that I will share a bit later. Okay. First of all, we must go back to the definition of root mean square current. Root mean square current is actually, if you read the lecture note, is the steady current, like a steady DC current that produces the same power as the average power produced by the AC. That means, what is the significance? They learn about root mean square current. So, what is root mean square current? It is the current that we use to calculate the power consumption of all these different electrical products. That means, why do students need to learn about root mean square current? Because we need the root mean square current to calculate the power consumption of all these electrical appliances. How much power is used by each of these electrical appliances? So we need the root mean square current, and after we know about their power, we can calculate our energy bill. Students will know about their energy consumption, how much bill they have to pay at the end of the month. So that is why they need to know about root mean square current. It is a value we use. It is the value. It is a value, root mean square current multiplied by the root mean square voltage. It is the value we use to calculate the average power, the power consumption of all these electrical appliances. Okay, and how in the coding? That's why I like Arduino, because it integrates about computer science with physics. It's we can say about like STEM. STEM is about like integrate between different branches of science. So I use coding. In the coding, they learn about if-else statement. Actually, in the coding, it used just a simple if-else statement, the conditional statement, to find the peak current. Okay, first of all, how do I actually get the root mean square value? Very simple. Very simple. In the coding, I just have to find the peak current. So just now the ACS712 current sensor, I analog read. That means I take the input. Read the input, read for 1,000 values. 1,000 values, that's why only Arduino can do this job. We cannot do this measurement. We cannot do it manually by humans, taking measurement one by one. Cannot. We must use technology to do things like finding the root mean square current. We must use technology. Imagine you want to do 1,000 measurement within 1 second. It's impossible. Only technology can do it. So, alright. So I take the reading. That means within this 1,000 reading, I check if-else statement. That means if I get, let's say, the first reading as set as a maximum, and then I get the second reading. Let's say the second reading is bigger than the earlier reading. So I set the second reading as the maximum, and then I check the third reading. I check the third reading is lower if the reading is lower than the earlier reading, then nothing happened. Then I check the fault reading. The fault reading is higher than before. So that the fault reading become the new maximum. So I do the same process for 1,000 readings until finally I can get the peak current. Actually, this coding, no need to worry. You can, because the day I do this coding, of course, I check a lot of YouTubes, but nowadays we have ChatGPT. You just type in your prompt, you can get all this coding, but easily. You can get this coding easily. What I want to say is, this project can easily replicate by anyone. You just have to have the intention to do it and the idea to do it. Yeah. So the peak current, okay, so this coding is just to check the peak current, and after I got the peak current from 1,000 reading, I multiply by this number 0.7071. I'm sorry if I take more time, but please remind me if I take extra time, so I can stop. Okay, so 0.7071, I multiply here, as you can see in the coding. Yeah, so you can see physics inside the coding. Multiply 0.7071, it is equivalent to 1 over sub2. That is a formula to calculate the root mean square current. Yeah, because in the coding we cannot put in equation. We can only put in values. That's why I multiply 0.7071 and I get the root mean square current. After I get the root mean square current, I multiply by 240. So this Arduino kit, it does not measure the root mean square current. I just regard the root mean square voltage. I just regard the root mean square voltage as 240 volt in Malaysia. So this kit is just to measure the root mean square current. After measure the peak current. After the peak current, I got the peak current. The Arduino calculate the root mean square current. Get the root mean square current, multiply by the 240 volt, if you can see here. Multiply by 240 volt to get the power consumption of the electrical product. Very simple coding. But students, if any students interested to know about the coding, I can easily explain to them the computer science theory about if else. The use of if else is used in the coding. And the variables, concept of variables, double, long, integer, float, these things, this is actually C++. Yeah? So students can learn a lot of simple programming knowledge here. Okay, so these are some example, okay, of
electrical appliances.
This is motor. This is the vacuum cleaner. You see?
Electrical
sorry. Now, you see, initially high power. I got the root mean square current. I calculate the average power. Initially is high current, high power. But then you see, I use yellow LED to show high power. Above 1,000 watt is high power, and then after that it becomes green. That means low power, below 1,000, 450. Okay, that's it, I think. So yeah, it's a bit different from the label. Okay, I don't know which one is. Maybe the label, I'm a bit doubt about the label whether it's correct or not. But if you look at the heat one, yeah.
Yellow LED, high power,
yeah,
1,004.
Yeah, see that? So if the heat one is accurate, yeah, 1,400, almost there, yeah, 1,400 watt. So yellow LED. So you can see difference between motor and heat. Motor, okay, the one with motor, vacuum cleaner and water drill, all below 1,000, but the one with heat, all high current, high power. That's the use of root mean square current. It's used to calculate all these power consumption values so that they know how much power they use by all these electrical appliances. So one thing the children also learn about this project is they now realize why in the dormitory, in their college, they prohibit students from using water kettle, cloth iron, toaster in the dorm. Yeah, because use a lot of power. One thing, waste energy, and it has a lot of, it use a very high current, and it might cause electrical hazard, electrical fire. So that's why in the dorm they disallow students from bringing in all these electrical appliances. Yeah, but things like motor and the vacuum cleaner wardrobe is very low power, not a big problem. Like our PC, our handphone charger, all that's not a big problem. Yeah, very low. They use very low current, very low power. But the one with heat, like water kettle, all this, you want to water kettle, right? Iron. Students normally need to use this product, but cannot because they use a lot of power. They will cause electrical fire. Yeah, so this. Yeah. So I also try some ESP32. These are some like IoT. They can send the data to the user phone through wirelessly. Can also show the reading in the phone actually. This is Blink app, using Blink app. Yeah. So these are some feedbacks from students. Yeah. Just now, one more thing learned from the project is I also check the socket. I check the socket. The maximum current by the socket normally is 13 ampere. 13 ampere. That means how do you cause an electrical hazard? Yeah, 13 ampere. The current limit is 13 ampere. So if you go back to go back to go back to this value here, 13 ampere. Okay, so for calculating the power consumption, we use root mean square current. Yeah, we use the root mean square current. But to check electrical safety, we must consider the peak current. Because the current is going up and down. It's an alternating current going up and down. So the current does not remain remain the constant value. It's going up and down. So that means the current can go above the root mean square current. We call it the I naught, the peak current. Just now I measure from the current sensor. The peak current. So imagine if the students, they use a cloth iron and a toaster at the same socket with current limit 13 ampere. They connect cloth iron and toaster at the same socket, which is around 7 ampere here and 9 ampere here. 7 plus 9 is 16. 16 ampere, more than 13 ampere. It will cause electrical hazard. So for electrical safety, we don't use the root mean square current. We must use the peak current. So students will realize, they cannot use these two heat products with the same socket at the same time. It will cause, they now realize it will cause electrical hazard because it go over the 13 ampere current limit. Okay. And then students actually, I do some physics open day. Actually, a lot of other projects I have done actually. And I love the physics behind. Even I do a remote control. They learn about infrared. Talk about hexadecimal. They got all the coding. The transmitter, the receiver. Infrared is electromagnetic radiation. And how does the remote control function? How does the remote control function? Actually, it's just blinking like super fast Morse code. The transmitter blinking the Morse code very fast and received by the transmitter. This transmitter is at our remote control, and the receiver is at our TV. You actually have to point. You have to point directly to the transmitter. If not point, it cannot work. Like our aircon, all this, you need to point directly because infrared travel in straight line. Because light travel in straight line. Unlike our car key don't have to point directly. That one we just point anywhere because car key is not infrared. It's based on radio wave. So they will learn physics behind. So you can see, I made a custom button. I show students about this, hexadecimal. For example, like FF10EF. F is actually 1111. That means the transmitter is on, And then let's say the 3 is 0011. That means off 11. That means the LED is flashing on, off on. Then the transmitter will translate it to the actual code for the different button in the remote control. Yeah. So I love the physics. Even one more thing about infrared. One thing I realized after doing Arduino projects, I learned that infrared, you can see the video here. Can you see here? This is infrared. Actually, if we look directly at our remote control, it's invisible. Our human eye is not so sensitive. Our human eye can only see a very limited range from 400 to 700 nanometer. But there are actually outside in our world, there are a lot of other rays that human eye cannot see. But camera can see. Camera can see just now what you see. This infrared. Infrared is outside of our human eye range. Yeah, but camera can see. Camera is more sensitive than human eye. It can catch the infrared. Yeah, so it makes students to realize that, oh, it's not just the thing I see in the world, but there are many other invisible things exist. And what is the proof of existence? This is the video to prove that infrared exists, even though it's invisible. Yeah, but camera can see. Okay. You can use simple RGB LED to show the different component of light. You see, and they learn about potentiometer here. Potentiometer. I use you. Okay, what is RGB LED? RGB LED is one LED can emit 3 different kind of light. That means red light, green light, blue light. I'm sorry, I'm taking too much time. Yeah, but sorry. So okay. So red LED, green, blue. Okay. So like educators can use this to explain about components of light. Okay. Just show this. Show this video.
The RGB light and blue color.
See that?
Okay.
Red.
Okay. Now I
sorry.
created the RGB light and blue color.
You see red? That means red. Okay. After that, I can convert to
Blue.
purple. Just now I said the RGB LED only can have red, green, blue. But how do you get purple? How do you get purple? Because I use potentiometer to control the intensity of light here. That means I make the potentiometer, I increase the intensity of red, and I increase the intensity of blue a little bit, mix together by a ping pong ball, and get a purple.
I get a purple, or we call it the colors. Yeah.
Blue. Why I get blue here? Why I get blue here? Because I turn off the red. I turn off the red, only have blue.
It's all the green.
How do I get yellow? RGB LED don't have the yellow color. But how do I get yellow? Because I turn on the red color a little bit, I turn on the green a little bit, they mix together, become yellow.
The blue.
Now, I get white here. You see that? How do I get white here? I turn all red, green, blue to the maximum. I get a white color. So students, okay, you say white light consists of many color. Yeah? How do you prove that? How do you prove that? Without a physical setup. So this is the thing you can show. We can show. I mean, we can show to students white light. That means if I mix red, green, blue, I don't get a black color. I don't get a black color. Red, green, blue, I get a black color. But I just get a simple white color. White color consists of all. If you look at the rainbow, it consists of 7 colors. All different colors. So this you can show different color.
The red, the green, and the blue.
All right, that's enough. So, yeah, potentiometer. Potentiometer is based on potential divider principle. The beauty of physics behind it. Later I will show it. This is so the red, green, blue. The red, green, blue. Yeah, that means it's based on potential divider. Yeah, potential divider means low resistance, low voltage, high resistance, high voltage. That means it can use to turn something to minimum, turn something to maximum. So here the function of potentiometer here is I can use it to turn the red light to minimum or turn the red light to maximum using a potentiometer. If I need to control 3 different color, I use 3 different potentiometer. Okay, so Arduino in rotational motion, you can easily use Arduino to, measure very high speed rotation. For example, like you see here,
by this toy aeroplane, toy aeroplane. So I want to rotate this thing and
okay. So how to measure the very fast rotation here? Impossible for us human eye to measure. We need technology. So you can see I can easily measure how many rotation made by this. I learned this from YouTube. Yeah.
How many?
So
one turn.
You see, 1 turn,
and then
2 turn,
2 turn, and then 3 turn.
See that?
Okay.
You see, become 23 turn, 35 turn, 48 turns easily, even though the circular motion is very fast. You can get the answer, you can get the value in split second. Alright, so this is what we call the infrared sensor. Infrared sensor, IR sensor. Do you notice that I use a white strip here, a white paper here? A white paper here, why do you need a white paper? Also got physics concept. Because white surface reflect light better than black surface. Yeah, and this is how to get the angular displacement, number of revolutions. If I multiply by 2 pi radian, I get the angle of angular displacement in radian. Yeah, and you look at this angular velocity, RPM.
Stop.
You see that? I can get the velocity, angular velocity in RPM. Yeah. Yeah, so you can see, physics concept behind the infrared sensor. The white color is actually a good reflector of light, but the black color is a good absorber of light. Yeah, the proof. Why? Okay, you can easily say white color reflect light, black color no. But what's the proof? Where's the proof? Okay, this is what we call the infrared sensor, which I used earlier to find the angular displacement of the what is it called, the toy plane. Yeah, so how it function is, you can see there are 2 LED here, one is actually the transmitter, one is the receiver. The black one is the receiver, the white one is the transmitter. So this infrared, it actually give out a signal called an infrared signal. Give out infrared signal, and then it is reflected by, you need a surface to reflect. Yeah, that means something passed by the infrared sensor. Then this infrared signal can detect. Yeah, how it detect? It means infrared signal come out a signal, transmit a signal, and then it is reflected by the passing by surface, and then reflected, and then the receiver receive the signal and consider there is an object in front. If there is no object in front, so the transmitter don't send, the receiver don't sense the signal the infrared given by the transmitter. So got object, you register as 1. No object, register as 0. Because Arduino is all about 1 and 0. Yeah. So you see here. Do you see I put a white strip there? Okay, maybe I should show this one first.
Good reflector of
you see the blinking here. One white surface, got blink. What about black surface?
That's why my infrared sensor can
black surface black surface don't blink at all, because black surface no light is reflected, but white surface is reflected. So the white light the white surface, this can prove that the white surface reflect light, the black surface absorb light. Yeah. See that?
Black is
the black color
absorber of light. That's why my infrared sensor can.
That's why like this is the what we call the flywheel. They're black, actually made of black. So my infrared I put an infrared sensor here. It cannot detect the black surface. It can detect only the white surface. That means if the white strip travel 1 turn, so the sensor knows it passed through 1 time. That means there is a 1 rotation. If it passed by many times, let's say it passed by 10 times, So my infrared sensor know there is a 10 rotation there. That's how I get the reading of the number of revolutions, even though it's very fast. Okay, but Arduino can do the measurement very fast, 1,000 reading in 1 second. See that?
1, 2, 3.
See that? Yeah. See that? So that's how. Yeah. Okay. Why? Freeform motion, I also use I use a white object. Why there's a white object here? Why I use? Because I need a white surface. The gravity value is 9.81. Easily, without doing graph, without drawing the graph, it can straight away show. Yeah. Even even like the waving scale. Even we can use this digital Arduino in doing a waving scale. It use a load cell. Load cell. So like you see here,
Waving balance. Okay, right
digital
now,
waving scale.
Okay, let's test it on my waving balance. Wow!
87 gram. See that? Very small mass. It's very small mass. Traditionally we use spring. We use spring scale in the school. In the school we use spring scale. But for now we actually use load cell. Load cell is actually we don't base on force. It's based on voltage. That means actually this big new Wheatstone bridge concept actually is one of the concept in electrical circuit, Wheatstone bridge. Initially, if let's say no mass, there's no mass. So all these are, let's say, 1,000 ohm. You can see all these is 1,000 ohm. But when you put a mass, these the blue part, these two blue resistor here, they are being extend. When we extend, they get higher resistance.
Mr. Peck,
Okay.
is it possible to conclude your session? Thank you. Sorry.
Yeah. Okay. So actually, one last thing is this is a photoelectric effect. Even the LDR they use to measure is about photoelectric effect, and the capacitor is used to measure the capacitance. So a lot of other things. Okay, so that's it. So the things to conclude is that's why we can appreciate the beauty of physics behind this. Yeah, behind the technology. Okay, so that's all for my presentation. Thank you.
Okay. Thank you so much, Mr. Pek Chun Ho. After listening to your session, now I know why we were not allowed to use water heater when I was, at the boarding school. Thank you so much. Okay, we would like to welcome Dr. Mio Hamdan, Pegawai Pendidikan Daerah, Pejabat Pendidikan Daerah Kinta Selatan, who just joined our symposium. Selamat datang, Dr. Mio. Thank you so much. Okay, so we would like to continue, with our, if there is a question for Mr. Peck, I would like to get the audience to write your question in the chat box, because we would like to continue with our second speaker. So please, if there is any question for Mr. Peck, please write in the chat box, ya. Okay, tuan-tuan dan puan-puan, simposium ini akan diteruskan dengan ceramah yang akan disampaikan oleh Cik Lee Cindy. Beliau merupakan pensyarah kanan di Jabatan Sains dan Kejuruteraan di Pusat Pengajian Asasi Universiti Tengku Abdul Rahman, UTAR. Beliau memiliki ijazah sarjana sains dan ijazah sarjana muda dalam bidang biologi dari Universiti Putra Malaysia. Kerjaya akademiknya bermula pada tahun 2014 di jabatan yang sama di mana dia mendapati minatnya untuk mengajar dan membimbing para pra-universiti pelajar dalam memahami selok-belok sistem fisiologi selain sel asas dan biologi moden. Dia berusaha untuk menjadikan konsep yang kompleks boleh diakses dan difahami oleh pelajarnya dengan kaedah pengajarannya yang menarik dan interaktif. Beliau merupakan salah seorang penerima anugerah kecemerlangan E-Pembelajaran UTAR 2023. Tuan-tuan dan puan-puan, Majlis dengan ini mempersilakan Cik Lee Cindy untuk menyampaikan perkongsian beliau yang bertajuk Engaging Students Beyond the Classroom. Dipersilakan Cik Lee Cindy.
Thank you, Puan Nurul. Allow me to share my screen. Okay, you can see my screen.
Yes, Cindy, can.
Thank you. Alright, thank you. So, very good morning, selamat pagi, Profesor, Doktor-Doktor, Tuan-Tuan dan Puan-Puan. Tanpa melengahkan masa, saya akan mulakan perkongsian saya pada hari ini. Nama saya Cindy, saya merupakan seorang pensyarah di Universiti Tunku Abdul Rahman Center for Foundation Studies, kampus Sungalong. Pada hari ini saya akan berkongsi tentang bagaimana kita boleh melibatkan pelajar dalam proses pembelajaran di luar bilik darjah. Bagaimana kami boleh berinteraksi, masih boleh berinteraksi dengan pelajar apabila tamat waktu kelas. Jadi saya akan berkongsi sedikit sebanyak tentang cara-cara kita boleh berhubung dengan mereka. Jadi selari dengan tema kita pada hari ini iaitu pembelajaran atau pengajaran pedagogi diademik, mari kita menerokai cara-cara untuk menyediakan dan juga menyampaikan barang-barang, bahan-bahan pembelajaran atas talian kepada pelajar-pelajar kita. Saya juga akan berkongsi tentang beberapa contoh yang telah sedia ada dan boleh digunakan oleh pelajar kami di sini. Apabila kita bercakap tentang e-pembelajaran ataupun pembelajaran atas talian dan bahan elektronik, pada asasnya ia bermaksud bahan-bahan yang boleh disampaikan melalui peranti elektronik seperti handphone, laptop ataupun tablet. Saya pasti bahawa kebanyakan ramai pelajar sekarang hari ini mempunyai at least sekurang-kurangnya salah satu daripada apa yang saya sebut tadi, terutamanya handphone dan juga tablet. Jadi kita juga perlu menerokai cara pembelajaran jarak jauh. Kita akan lihat kenapa aspek-aspek ini penting bagi kita cuba pada masa yang akan datang jika tidak pada hari ini atau belum pada hari ini. Tugas kami adalah untuk membantu pelajar belajar secara berdikari ataupun is either self-learning atau independent learning, iaitu pembelajaran berdikari ataupun pembelajaran kendiri. Kedua-dua ini adalah penting kerana kita ada banyak batasan, had yang kami lalui dari segi pembelajaran dalam waktu kelas sahaja. Jadi saya terfikir apakah strategi cara-cara yang boleh kita guna pakai dalam mengaplikasikan pembelajaran di luar bilik darjah. Jadi semestinya kami boleh menggunakan media sosial seperti Facebook atau YouTube, gamifikasi permainan sambil belajar, juga kajian-kajian case ataupun lawatan sambil belajar, penggunaan apps kepada mereka seperti Encik Pat tadi yang pandai dari segi software, coding, mungkin boleh menggunakan aplikasi. Tetapi dalam kes saya mendapat peluang untuk menggunakan LMS, Learning Management System, iaitu sistem pengurusan pembelajaran, juga laman web dalam menggunakan mengaplikasikan pembelajaran atas talian. Di UTAR, kami mempunyai web-based learning environment, iaitu kami short form panggil Webble, di mana semua pelajar dapat mengakses website ini dan how do I say, akses mana-mana subjek yang mereka minati. Jadi ini adalah salah satu platform yang kami ada untuk menyampaikan bahan-bahan yang telah disediakan. Jadi kita perlu lihat mengapakah kita perlu menerokai dan juga menggunakan platform ini. Apakah kelebihan dan perlunya e-pembelajaran sebagai bahan tambahan atau sampingan kepada apa yang telah diajar di dalam kelas. Pertama sekali kami